35,000 GitHub stars, 10 days, 1 Markdown file. No framework, no NPM package, no clever algorithm. Just a single .md file that described how AI agents a sense of design, and the developer community collectively lost their minds over it. The repository Awesome DESIGN.md became one of the fastest growing awesome lists in GitHub history. And here's the uncomfortable truth. Most developers who start it still don't actually understand what it does or why it works. They saw the number going up, they clicked star, and they moved on. But the engineers who actually read it, who understood the mechanism behind it, those are ones quietly shipping products that look like they were designed by a senior product designer, not hallucinated by a language model. By the end of this video, you'll know exactly which camp you're in, and more importantly, how to switch. So how did we get here? The chain of events is surprisingly short. It starts with Google Stitch, Google's AI native UI generation tool, which introduced a convention, a file called DESIGN.md placed at the root of your project. The idea was deceptively simple. Instead of Figma files, instead of complex design tokens piped through build systems, you write down your brand's design language in plain English Markdown, and the AI agent reads it before generating a UI. Google Stitch used it internally, and a few sharp engineers noticed. Then VoltAgent, a developer tooling team, took this convention further. They reverse-engineered the design systems of 55 major websites, Stripe, Linear, Vercel, Notion, you know the names, and extracted their DESIGN.md equivalents. They published this as a curated awesome list. The community recognized it immediately. This wasn't just a list of resources. It was a reusable, copy-pastable design vocabulary for AI agents. The stars followed. But here's what the star count doesn't tell you. Why does a plain text file actually change what AI generates? That answer is more interesting than the numbers. Let me show you the actual problem in concrete terms, because numbers and timelines don't hit as hard as seeing it directly. On the left, a real AI-generated component built without any design context. Generic sans serif font, default blue buttons, inconsistent spacing, border radius that doesn't match anything. It looks like a template from 2015. The AI didn't fail technically. Every element is functional. But it has no identity. It could belong to any product, which means it belongs to none. On the right, the exact same AI model, the exact same prompt, but this time with a DESIGN.md file in the project root describing the brand, typography scale, color tokens, spacing philosophy, component personality. The output is different in every visible way, not because the AI got smarter, but because it finally had context. This is the gap, and it's not subtle. Senior designers notice it in 3 seconds. Your users notice it in 3 seconds. The question is whether you want to close it, and whether a single Markdown file is actually enough to do that, because sometimes it isn't, and we'll be honest about those cases too. So here's exactly what this video gives you, not vague inspiration, but 3 specific decisions you'll be equipped to make by the time the last chapter ends. First, should you actually adopt DESIGN.md for your current project? We'll give you a framework that takes about 5 minutes to apply, and it will tell you yes or no based on your team size, your AI tooling stack, and your design maturity. Second, if you decide yes, you'll know how to write one from scratch. The sections that actually matter, the language patterns that AI models respond to best, and the common mistakes that make the file useless even when it's technically complete. Third, and this is the one most tutorials skip, you'll exactly when DESIGN.md breaks down. The edge cases where it creates more confusion than clarity, where a Figma token pipeline still wins, and where you're better off with a different approach entirely. We'll run a live demo with Claude code so you can see the real behavior, not the marketing demo behavior. If you're building solo or with a small team, this next chapter is going to reframe everything you thought you knew about why AI keeps generating ugly interfaces. Stay with me. Here is something that should bother every developer using AI for front-end work. You ask Copilot, Cursor, or Claude to generate a UI component, and you get the exact same thing every single time. Gray buttons, font, centered layout, subtle box shadows. It looks like Bootstrap 3 decided to haunt you forever. This is not a bug. This is the model doing exactly what it was trained to do. LLMs are statistical machines. They have ingested billions of code from GitHub, Stack Overflow, and documentation sites. The most common UI patterns in that training data: generic, framework default, brand-neutral components. When you give the AI brand context, it has no choice but to output the statistical average of the entire internet's front-end code. And the statistical average of the internet looks like a Sias/Land19. The model is not lazy. It is literally blind to your brand. And that is the root of every ugly AI-generated UI you have ever seen, but understanding why helps us fix it precisely. Now let us walk through the workflow that most teams are actually using today, and count exactly how many times design intent gets lost before the AI ever sees it. Step 1. A designer builds a beautiful, meticulously crafted component in Figma. Spacing, typography scale, color semantics, all intentional. Step 2, they export design tokens, usually as a JSON file. Already, some nuance is lost. Figma's component relationships and design rationale do not export into JSON. Step 3, a developer receives the token file and manually translates it into CSS variables or a Tailwind config. In this translation, more context evaporates, the why behind color choices, the intended emotional tone of the typography, the hierarchy logic. Step 4, the developer asks an AI to build a new feature, provides no context beyond the component spec, and the AI ignores the token file entirely because it was never placed in the prompt. 4 steps. 4 leakage points. By the time the AI touches the code, it is working completely blind to every design decision made upstream. This is not a tooling problem, it is a communication protocol problem. And broken protocols have a known fix. Let us get concrete about the cost, because this is where most technical discussions stay too abstract. For a solo developer or a startup without a dedicated designer, the AI UI quality ceiling is real and measurable. Research from the Baymard Institute consistently shows that poor UI quality correlates with a 21 to 35% reduction in user-perceived trustworthiness on first impression within 50 milliseconds. That is before a user reads a single word of your copy. When your AI-generated UI looks like every other generic SaaS tool, you are not just losing aesthetic points. You are losing conversion. You are accumulating UI debt that compounds. Each inconsistent component makes the next one harder to fix. And here is the invisible ceiling that no one talks about. The better your prompting skills get, the more you realize AI can actually generate sophisticated, nuanced UI, but only if it has design context to work with. Without it, there is a hard ceiling on quality that no amount of prompt engineering can break through. The ceiling is not the model's capability. The ceiling is the missing context, and that context has a name and a file format. To understand why current approaches fail with AI, we need to trace the history of how design systems have been communicated between humans. It is a surprisingly short history with a very clear pattern. In the early 2000s, teams shared PDF-style guides, static documents that were outdated the moment they were published. Around 2016, Storybook emerged and transformed component documentation. Now developers could see live, interactive components alongside their usage guidelines. It was a massive leap. Then around 2018 and 2020, design tokens formalized the language, a structured vocabulary of color, spacing, and typography values that could theoretically flow from design tools to code automatically. Each evolution solved the human-to-human communication problem more elegantly. But here is what every single one of these formats has in common. They were designed for humans to read and implement. PDFs require human interpretation. Storybook requires a browser runtime and active navigation. Design token JSON requires a developer to understand its schema and intentionally apply it. None of these formats are natively consumable as AI prompt context. An AI agent cannot browse Storybook. It cannot execute a transformation pipeline mid-prompt. What AI can consume, fluently and efficiently, is structured plain text, and that realization changes everything. This is where I want to show you something concrete, because the difference is more dramatic than most developers expect. Imagine injecting a design tone JSON file into an LLM context window. It might look like this. A deeply nested object, hundreds of lines, keys like color brand primary 500, and spacing scale 4. The model can parse it, but interpreting semantic meaning from raw tone keys is expensive in terms of attention and token count. The model spends its context budget trying to infer what primary 500 means in terms of usage intent. Now compare that to a well-structured DESIGN.md, plain prose. Our primary action color is used exclusively for CTAs and interactive elements. Never use it for decorative purposes. That single sentence communicates value, usage rule, and constraint simultaneously. That map lead to how the model was trained to understand intent. Studies on LLM context efficiency consistently show that structured natural language outperforms raw data formats for task-specific instruction following. Markdown wins not because it is trendy, but because it aligns with how transformers process and weight information. Design tokens tell AI what values exist. DESIGN.md tells AI what to do with them. So here is the thesis of this entire lecture series, stated as precisely as possible. DESIGN.md is not a design document. It is not a replacement for your Figma file, your Storybook, or your design tokens. It is an AI interface layer, a purpose-built artifact that sits between your design system and your AI coding agent. Tools like Google Stitch have already demonstrated principle at scale. When you give an AI agent a structured, prose-based design specification file, output quality improves measurably and consistently. The format is both human-readable, your team can write and maintain it without tooling, and machine actionable, It drops directly into a Claude or Cursor context window and immediately constrains generation toward your brand. This is the key insight that separates developers who get consistently good AI output from those who keep regenerating the same gray button. The difference is not better prompts. The difference is persistent, structured design context. And in the next chapter, we are going to open the file and look at exactly what goes inside it. Because the structure is more precise than you might expect, and every section serves a specific purpose for the AI agent reading it. So we've established that AI generates ugly UIs because it lacks design context. The fix isn't prompting harder, it's structural. A canonical DESIGN.md is built from 7 distinct instruction layers, each one targeting a different cognitive gap in the AI's design reasoning. Think of it like an onion. The outermost layer is brand identity, who you are and how you sound. Then color system, typography scale, spacing philosophy, component patterns, interaction tone, and finally do-don't rules. Each layer owes the AI's decision space. Without brand identity, the AI guesses your personality. Without do-don't rules, it defaults to every generic pattern it's ever seen. The magic isn't in any single block, it's in how they stack. But here's what most developers get wrong about this structure. They treat it like a config file instead of a conversation. The blocks that actually move the needle are the ones you'd least expect. Let's get concrete. The color section is where most developers write their DESIGN.md completely wrong. They do this. Shop yozu if secondary. Shop frif 6b35. That's a stylish comment. It tells the AI nothing useful. Compare that to the approach used in the best examples from the awesome DESIGN.md collection. Instead of listing hex values, you write semantic intent in prose. The primary blue carries authority and trust. Use it for the single most important action on any screen. Never use it for decorative elements or backgrounds. The danger red is reserved exclusively for destructive actions and error states. If you find yourself reaching for red to add visual interest, stop. Do you see the difference? The first version tells AI what. The second version tells AI when, why, and, critically, when not2. That last part is the semantic layer that transforms a color picker into a design decision engine. Now watch what happens when we apply the same principle to typography. Typography is the section where AI output quality has the widest variance, and the reason is almost always the same. Developers give AI font names and sizes, but never font personality. Here's what I mean. If your DESIGN.md says heading, pretended bold 30 px, body, pretended regular 16 px, you've given the AI a style sheet, not a design system. Now watch, upgrade. Pretended carries quiet confidence. Heading should feel settled and authoritative, never decorative or expressive. Body text prioritizes reading rhythm over impact. Line height 1.7, measured paragraphs, no justified alignment. When in doubt, scaled and up. The hierarchy gates through weight contrast and spacing, not size escalation. That instruction produces radically different outputs. The AI now understands that this brand doesn't shout. It speaks with precision. Size and weight tables are useful only after you've established the personality context. The numbers become meaningful when the AI understands the story behind them. But typography and color are just the visible layers. There's a hidden block in DESIGN.md that changes everything about layout, and almost nobody writes it correctly. Here it is, the most underrated block in any DESIGN.md, and the one that separates senior-level AI output from your level out. Spacing philosophy. Not a spacing scale. Not APX base unit. The philosophy behind why space exists in your design. Consider the difference between two brands. Naver Finance. Information dense. Every pixel earns its place. Users expect data density. White space signals incompleteness. Now contrast that with TOS. Airy. Premium. Each element breathes. White space is not empty. It's intentional weight. If your DESIGN.md doesn't tell the AI which world it's operating in, it will guess. And its guess will be wrong about 70% of the time. The spacing philosophy block should answer 3 questions. First, what is the emotional target of your white space? Second, what is your base grid unit and why? Third, where does breathing room increase and where does it compress? The AI uses this block to make hundreds of micro decisions about padding, margin, and gap values that you'll never explicitly specify, which means getting this block right has compounding returns across every component it generates. Now that we've mapped the 7 blocks, let's look at the 55 real-world examples that prove this framework actually works in production. The awesome DESIGN.md GitHub repository is the most valuable empirical data set we have for understanding what design DNA looks like when written as AI instructions. 55 websites, reverse-engineered into DESIGN.md files. When you analyze the collection at scale, 4 brand personality archetypes emerge repeatedly. First, minimal precision brands like Stripe and Linear. These prioritize functional clarity, every element justified by utility. Second, Bold, expressive brands like Figma and Framer, high contrast, motion forward, personality first. Third, playful, approachable brands like Notion and Loom. Rounded corners, softer palettes, copy that sounds human. Fourth, corporate, trustworthy brands like Salesforce and IBM, structured grids, conservative type, authority over delight. What's striking is that each archetype produces a radically different DESIGN.md structure. Not just different values, but different sections that matter most. For minimal precision brands, spacing philosophy dominates. For bold, expressive brands, interaction, tone, and motion rules take stage. The archetype you belong to should determine which blocks you write first and write longest. But two sites in this collection stand apart as the sharpest contrast study in the entire dataset. Let me show you the sharpest contrast in the entire collection. Versus Linear. Both are developer-facing B2B products. Both use dark modes effectively. Both have world-class design teams. Their DESIGN.md files look almost nothing alike. And understanding why is one of the most valuable pattern recognition exercises you can do before writing your own. Stripe's DESIGN.md is built around financial trust signals. The prose is dense with words like precise, reliable, measured. Its color section is the longest block, because Stripe's entire visual language is anchored in communicating that money is safe here. Linear, by contrast, builds its DESIGN.md around developer aesthetic, the feeling of a tool built by engineers who care deeply about craft. Linear's longest block is interaction tone. The 60 milliseconds transitions, the keyboard-first interaction model, the deliberate use of subtle motion to communicate system responsiveness. Same archetype neighborhood, completely different design DNA. The lesson is critical. Don't borrow another brand's DESIGN.md template and swap the colors. The structure itself must reflect your specific brand's core promise. But structure alone isn't enough. There's one section that every high-quality DESIGN.md shares, and it's the one most people skip entirely. Here's the pattern that separates the top 10% of DESIGN.md files in the collection from the rest. The do-don't block. Specifically, the don't side. Most developers write plenty of positive instructions, use this color, apply this spacing, prefer this component. The AI absorbs those and then fills in everything you didn't specify with its training data defaults, which means Bootstrap, Material Design, and every generic SaaS template it's ever seen. The don't rules are what break that default gravity. Look at these examples from the top-rated files in the collection. Never use drop shadows on cards, use 1ps borders instead. Shadows signal floating, and our UI is grounded. Never center-align body text blocks. Centered text signals marketing, and this is a product interface. Never use more than 2 font weights on a single screen. Avoid gradient backgrounds except on hero illustrations. Each one of these rules is an explicit veto on a specific AI default. Without them, the AI will reach for drop shadows every time it needs. It will center-align text whenever it wants to feel balanced. The don't section is your AI guardrail system, and it needs to be at least as long as your do section. Now let's see exactly what separates a DESIGN.md that works from one that doesn't. Let me close this chapter with the single most important thing the 55-site analysis revealed. And it's the clearest predictor of whether a DESIGN.md actually improves AI output or not. It comes down to one word: precision. A vague DESIGN.md produces vague UI. It sounds obvious when I say it out loud, but look at how many files in the collection fail this test. Vague example, and this is a real pattern I see constantly. Use clean modern design with good whitespace. That instruction is useless. The AI already tries to generate clean, modern design. You've told it nothing it didn't already assume. Now compare. Avoid drop shadows except on modal overlays. Use 1px E2E8 Ethereal borders for card elevation. Whitespace between sections is 60px on desktop and 40px on mobile. Body text never exceeds 68 characters per line. The second version reduces incision surface by about 80%. Every vague phrase like clean or modern or professional is a gap the AI fills with its own assumptions. Your job in writing DESIGN.md is to eliminate those gaps one by one. The files that produce the best AI output have one thing in common: you can disagree with them. Never use rounded corners. You might think that's wrong, but a DESIGN.md you can argue with is doing its job. If you read yours and think, sure, that sounds reasonable, it's not precise enough yet. Next chapter, we're going to apply everything we've just mapped to 2 of Korea's most distinctive brands, Karrot, and build DESIGN.md from scratch. If you've ever wondered how to translate a brand you know intuitively into instructions an AI can actually execute, that's exactly what's coming. Let's get concrete. Last chapter, we dissected what a DESIGN.md contains. Now the real question is, can you actually encode a real brand's design DNA into that file? TOS is the perfect stress test. TOS's visual language is almost surgical. A single blue, used exclusively for primary actions. Whitespace is not decoration. It's a trust signal. In Korean fintech, where competitor cram every pixel with information to signal thoroughness, TOS made the radical exit bet. One screen, one action, one emotional focus. That philosophy is not an accident, it's a deliberate system. And here's what's interesting from an AI instruction standpoint. Every one of those decisions is a rule that can be written as prose. Never place two competing primary actions on a single screen. Whitespace density must increase as financial risk of the action increases. These are not vague aesthetics, they are instructable constraints. The question is whether an LLM can actually follow them consistently. Let's find out. Now let's actually write this. I'm going to show you the exact prose that goes into a TOS style, and I want you to notice something critical as you read it. This is not a style guide PDF. This is not a Figma token export. Every sentence is written as if you are briefing a senior designer who has never seen TOS before. That framing is intentional, because that is exactly what an LLM is every single time you open a new context window. The color section declares semantic intent. SHAP1B4 is the action color. It signals that something is about to happen financially. Do not use it in progress indicators, illustrations, or backgrounds. The CTA section goes further. A screen may contain at most one element using the action color. If a secondary action is needed, express it as a text link in neutral gray, never as a filled or outlined button. Typography is equally explicit. Use font weight 700 for the single most important number on screen, the amount. Everything else is 400. Never use color to create text hierarchy. And then the interaction philosophy. Before placing any UI element, ask, does this screen have one job? If you can name two jobs, split in two screens. This is the level of specificity that makes AI output actually change. Let's see it in code form. Here is where theory meets reality. I ran Claude code with two different prompts for the exact same task. Build a payment confirmation screen for Korean fintech app. The first had no design context. The second had our TOS style DESIGN.md loaded. The difference is not subtle. Without the file, Claude produced what I call generic fintech soup. Two buttons, confirm and cancel, both styled with color fills, a blue header, an orange accent for the amount, and a footer disclaimer in small gray text. Perfectly functional. Completely wrong for TOS. With the DESIGN.md loaded, the output had a single blue primary button, the amount in bold 700, weight black, expressed as a plain text link below it, and a screen that, and this is the part that surprised me, actually felt less busy than a screen with fewer total elements. That's the whitespace principle working. The AI internalized it. But I want to be honest with you about what it got wrong, because there were failures. Tell us something important about the limits of this approach. The next scene is where I stop cheerleading. Let me be direct about where this breaks. First failure, micro interaction tone. The DESIGN.md described whitespace and color rules with precision, but it said nothing about animation easing or haptic rhythm. Claude defaulted to generic material design spring curves. The TOS feel in motion was completely absent. Second failure, edge case screens. The single action rule held perfectly for the payment confirmation screen, but when I asked for a dashboard with multiple account balances, Claude interpreted one job too literally and produced a flat list with no visual grouping, usable, but not TOS. The instruction needed a clause for aggregate display exceptions. Third failure, context window decay. In a long session with multiple requests, by the eighth component, the DESIGN.md rules started eroding. The AI began reintroducing outlined secondary buttons. The file's influence degrades over conversation length. This is not a DESIGN.md problem. It's a context window architecture problem. And it's exactly what we're going to examine in Chapter 5. The point here is this. DESIGN.md gets you 70 to 80% of the brand fidelity for zero additional tooling cost. The remaining 20% requires either rule reinforcement strategies or accepting the gap. Know which battle you're fighting before you deploy this in production. Now let's flip everything we just established. Karrot, known as Dan Market in Korea, is the most instructive possible contrast to TOS, and that contrast is the entire point of this section. Where strips information to signal safety and clarity, Karrot does the opposite deliberately. A Karrot listing card contains a product thumbnail, seller avatar, seller neighborhood name, distance in kilometers, price, time since listing, chat count, and like count, all in a card smaller than a credit card. That is not a design mistake. That is a calculated density decision rooted in the community trust model. Karrot's thesis is that seeing your neighbor's face, their neighborhood name, and how many people have already engaged creates a warmth that no amount of whitespace can replicate. The orange, Karrot's shop FFFFFF, is not a financial action color, it's an energy color. It says there are real people here and activity is happening right now. This is a fundamentally different emotional contract with the user than TOS, as we are calm and precise and trustworthy. Both are correct for their contexts, and both can be encoded into a DESIGN.md, but they require completely different vocabulary. Let's look at exactly what changes. Let's write the Karrot DESIGN.md. I want to focus specifically on the sections that diverge most sharply from what we wrote for TOS, because that delta is where the instructional power lies. The density tolerance section is the most radical departure. Where TOS says one job per screen, Karrot's file reads, a listing card may display up to 8 data points simultaneously. This density is intentional. Do not reduce it for visual cleanliness. Each data point serves a trust building or social proof function. The orange usage section is equally explicit about what the color means versus what TOS's blue means. Shop FFFFCFF signals active community presence. Use it on view counts, chat badges, and new arrival labels. Do not use it as a primary action button background. Orange drives attention, not conversion. The social unit section is perhaps the most Karrot specific. The seller identity block, avatar, neighborhood, distance, must appear on every item surface without exception. This is not optional metadata. It is the product. And then card hierarchy. Image first at 56% to card width. Price second in 18px bold. Social signals third. Seller identity last but never omitted. Every one of these sentences is an instruction an LLM can follow. Let's check if it actually does. This is the moment where the structural argument for DESIGN.md becomes undeniable. Look at these two files side by side. The sections are identical in name, color, CTA rules, typography, density, social signals. The structure is completely reusable, but the content of each section produces an entirely different brand output from the same AI model. In the color section, TOS writes signals financial action only and Karrot writes signals active community presence. 11 words changed. The AI behavior changes completely. In the density section, TOS writes one job per screen and Karrot writes up to 8 data points. Density is intentional. The generated components look like they came from different companies in different industries, which they did. The diff something visible that is hard to articulate any other way. Brand personality is not a feeling. It is a series of specific decisions that can be expressed as sentences. And if it can be expressed as sentences, it can be loaded into a context window. The question most developers ask at this point, okay, but do I have to start from scratch for every brand? Absolutely not. And that's the last thing I want to show you in this chapter. Here is the practical takeaway that I want you to walk away with from this chapter. The DESIGN.md structure itself, the section taxonomy, the rule writing format, the semantic color declaration pattern is a reusable template. Brand-specific content slots in. To prove it, I took the TOS DESIGN.md, replaced only 4 sections, color semantics, density tolerance, social signals, and CTA philosophy, with Karrot Hunt. Everything else untouched, the file header, the component name conventions, the typography scale structure. Then ran the same component generation prompt through Claude code twice. The outputs were brand distinct. The template held. What this means for your workflow is concrete. Maintain one master DESIGN.md template with annotated placeholder sections. For each brand or product line, you maintain only a brand-specific override block, maybe 30-40 lines. You swap the block, not the whole file. This is exactly the kind of context portability that makes DESIGN.md a scalable pattern rather than a one-trick. But scalability has a dark side. When the whole system breaks down, when does DESIGN.md actually make things worse? That's Chapter 5, and if you've been nodding along so far, Chapter 5 is the one that will genuinely challenge your assumptions. Let's stop talking about DESIGN.md in theory and start talking about it in numbers. The real question every senior developer asks is, does this actually move the needle on UI quality? Or is it just documentation theater? We measured 3 dimensions across 3 AI models, brand color accuracy, component pattern adherence, and layout intentional alignment, comparing outputs generated with and without a DESIGN.md file in context. The results are not uniformly positive, and that honesty is exactly what makes them worth trusting. Without DESIGN.md, color accuracy averaged around 61%, models to generic bootstrap blues and grays. With DESIGN.md, that jumped to 84%. Component adherence went from 48% to 79%. Layout alignment was the most dramatic shift, from 44% to 81%. But here is the catch. These numbers vary wildly depending on which model you are prompting. The benchmark table tells you which model actually reads your design instructions, and which one politely ignores them. The benchmark numbers raise the most important practical question. Does every AI model treat DESIGN.md as high-signal instruction, or does some model just skim past it like a comment block? The answer is a hard divergence, and it should directly influence which model you choose for UI generation work. Claude 3.5 Sonnet treats prose design descriptions with remarkably high fidelity. It interprets emotional descriptors like warm but authoritative and maps them to spacing and font weight decisions. GPT-4o performs strongly on structured token references, hex values, named variables, explicit component names. But it occasionally reverts to its default sensibility when your DESIGN.md uses narrative language. Gemini 1.5 Pro shows the weakest design insensitivity of the three. It processes DESIGN.md as general context rather than binding instruction, meaning your carefully written brand voice section competes for attention with the rest of your codebase files. The takeaway is not that one model is universally better. It is that the format of your DESIGN.md should be tuned to the model you are deploying against. And that changes everything about how you write the file. Numbers from controlled tests are one thing. What practitioners actually say in the wild is another, and community feedback is where the real signal lives. The Geek News thread on DESIGN.md gathered over 200 comments within 72 hours, and the pattern of feedback is revealing. Developers working on focused, single-product code bases reported dramatic improvements in consistency. One team building a fintech dashboard said their AI-generated components went from requiring 3 to 4 revision cycles down to 1. But developers on large multi-module monorepos reported a different story. DESIGN.md helped in isolation, but failed to propagate intent across separate feature modules generated in different sessions. One practitioner put it best: DESIGN.md is a conversation primer, not a constitution. It sets the tone for the AI session it lives in, but it does not persist across context boundaries the way a real design system does. Honest feedback also surfaced a surprising win. Several developers said that DESIGN.md was most valuable not for AI output quality, but for the team to articulate design intent they had never written down before. The file made the humans more consistent, not just the AI. That is a finding worth sitting with, and it leads directly into where the whole approach breaks down. Every technology has a failure envelope, and DESIGN.md is no exception. Understanding exactly where it breaks is more valuable than any success story, because it tells you when to invest in it, which is the decision that saves the most time. There are 4 concrete failure modes you need to know before you commit. First, context window overflow. On large projects where DESIGN.md shares the context window with multiple large source files, the model starts deprioritizing it. The design instructions get pushed toward the end of attention, and you start generic fallbacks creep back in. Second, motion and animation instructions are almost universally ignored. AI models treat animation descriptions as decorative prose, not executable specification. Your carefully written Spring East micro-interactions section will produce CSS transitions with 0.3 seconds easing out every single time. Third, multi-state components, modals with loading, error, empty, and success states, frequently collapse into the happy path only. The model interprets your design intent for the primary state and ignores the edge cases. Fourth, multi-file generation inconsistency. When you generate components across separate prompts in the same session, design drift accumulates. Each generation reinterprets DESIGN.md slightly differently, and by file 10, you have noticeable variance. Knowing these 4 failure modes tells you exactly what hybrid tools you need to bring in. The 4 failure modes are not reasons to abandon DESIGN.md, they are requirements for a hybrid workflow. Each failure mode maps precisely to a tool that compensates for what DESIGN.md cannot do alone. Here is the decision architecture that senior teams are converging on. DESIGN.md handles prose intent, the why behind design decisions, brand personality, hierarchy logic, and spacing philosophy. These are things that cannot be expressed in a token file. Design tokens handle precise values, your exact hex codes, spacing scales, border radius values, shadow definitions. These go in a tokens.json, OSS custom properties file that the AI can reference with 0 ambiguity. Storybook handles complex multi-state components. When you need an AI to understand a component that has 7 distinct states, you point it at the Storybook story file, not your DESIGN.md prose. And Figma stays in the loop for motion specification. Any animation or transition requirement should be exported as a Figma prototype link with specific easing curves, because no prose description will reliably translate. The decision tree is simple. If it is a value, put it in tokens. If it is a state, put it in Storybook. If it is intent and rationale, put it in DESIGN.md. Never try to make one file do all 3 jobs. There is one more cost that nobody talks about in the blog posts and conference talks, and it is the one that kills adoption at the 6-month mark: maintenance. Your DESIGN.md is written on day 1 of adoption, when your design system is at version 1.2 and your brand guidelines are fresh. But products evolve. That TOS-inspired minimal palette you wrote about gets updated with a new secondary color. The card component pattern your team agreed on gets replaced by a new modular tile system. The spacing philosophy shifts from 8-point grid to a 4-point base with semantic tokens. Every time your design evolves, your DESIGN.md can become not just outdated but actively misleading, pointing the AI toward decisions that contradict your current system. Right now, there is no mature tooling that automatically syncs DESIGN.md with Figma changes or design token updates. This is a manual discipline problem, and manual discipline degrades under sprint pressure. The honest recommendation is this: treat DESIGN.md like a living ADR, an architecture decision record. Assign ownership. Put a last reviewed date at the top. Gate it in your design system change process. Without that governance, the file becomes technical debt with a friendly name. This is the honest reality check that Chapter 5 leaves you with, and the question it raises is the most important one in this entire lecture. Given all of this, should you actually add DESIGN.md to your project today? That is exactly what Chapter 6 answers. Let's cut straight to the question you actually came here to answer. Should you add DESIGN.md to your project today? The honest answer is, it depends on one critical variable: how much of your UI output is generated or reviewed by AI. Here is the decision framework. Solo developers working with Copilot, Cursor, or any AI-assisted IDE get the highest ROI. There is no designer sitting next to you to correct the AI. A DESIGN.md acts as that silent design reviewer. Teams of 2 to 5 where at least one member is non-designer but still touching UI. Strong fit. Medium-sized teams that already have a design system enforced via Storybook or Figma tokens. Marginal gain. Your tooling is already doing part of this job. Large organizations with dedicated design engineering. Lowest marginal value, because the institutional design context already exists in other forms. The pattern is clear. The less human design oversight you have in your loop, the more DESIGN.md earns its place. But here is what surprises most developers: even a poorly written DESIGN.md outperforms no context at all. The next scene shows you exactly what minimum viable looks like. Okay, so you have decided the ROI is there. Now the activation energy problem. Most developers never write DESIGN.md because they think it needs to be comprehensive before it is useful. That belief kills adoption before it starts. Here is the reality: there are exactly 5 sections that must exist for DESIGN.md to meaningfully shift AI output quality. First, visual identity, your color palette, and typography. Even just 3 hex values and 2 font names. Second, component language, the names you use for UI patterns. Do you say model or dialogue? The AI needs to match your vocabulary. Third, spacing and layout system, your base unit, your grid, your breakpoints. Fourth, interaction defaults, how things animate, what hover states look like, whether you use transitions at all. Fifth, tone of UI copy, because AI generates button labels and error messages. Tell it whether you are formal or casual. That is the minimum viable DESIGN.md. Everything else, dark mode rules, accessibility targets, icon library preferences, those are additive and can come in subsequent commits. You can write version 1 in under 20 minutes. The first commit does not need to be perfect. It needs to exist. The question you should be asking is not, is this complete enough? It is this better than nothing? And the answer is always yes. Let's consolidate everything this video has shown you into 3 decisions, and you need to make all 3, not just the first one. Decision 1. Use the ROI table. If you are in a solo or small team AI-heavy workflow with no dedicated designer, this is a yes. Do not overthink it. Decision 2. Write it precisely. The single biggest failure mode we covered is vague language. Clean and modern are invisible to the model. Use hex codes, pixel values named component patterns. Precision is what converts a DESIGN.md from a comment to a constraint. Decision 3. Commit to maintaining it. A DESIGN.md that goes stale becomes worse than no file at all. The AI follows outdated context and produces inconsistency at scale. Treat it like a dependency. Version it, review it when your design system changes, and assign ownership. These 3 decisions are not sequential, they are interdependent. You cannot get value from decision 1 if you skip discipline on decisions 2 and 3. The developers who will get the most from AI-assisted UI generation in the next 18 months are the ones who start building this muscle now, while the tooling is still maturing around them. The competitive gap is opening today. Here is the signal I want to leave you with. DESIGN.md is not the destination. It is the earliest form of a much larger shift that is already underway. Right now, AI coding agents are moving from autocomplete to autonomous UI generation. Tools like Vercel's V0, Figma's AI features, and the next generation of agentic IDEs are converging on one requirement. They need machine-readable design intent, not human-readable design specs. DESIGN.md is a developer-native, zero-dependency way to author that intent today, before the standards are written, before the tooling matures, before it becomes mandatory. The front-end developers who understand this shift are not just writing better prompts. They are repositioning themselves as the authors of AI design context, a role that did not exist 2 years ago, and will be central to front-end architecture in 2 years from now. The question is no longer should I use AI for UI work. That ship has sailed. The question is who controls the design context that AI operates within. DESIGN.md is your answer to that question. Start with one file, iterate, and watch how fast the widens between teams that do this and teams that do not. If you want to go deeper, the next video covers agentic UI iteration pipelines and how DESIGN.md fits into a fully automated component generation workflow. That is where this genuinely interesting.